Welcome to today's AMA. I'm here with Thomas Wisbech from Energinet and André Bryde from Energinet. And we are here to talk about how Energinet is using blockchain to make green certificates. So we've had a lot of comments from our community. We've had a lot of questions. So what we have done is we have taken most of the questions and put them in to begin with, and then we have an open session at a later stage in this AMA. And to start with, I think I will give the word to André. And the first question that I think is really a good one is, what is a TSO, and what is it that TSO does? And when I say TSO, everybody thinks that probably doesn't know what it means, a TSO as well.
Entirely fair enough. Let me explain. Energinet is an organization under the Ministry of Climate, Energy and Utility in Denmark. We are, as you say, a TSO. What is that? A TSO is a transmission system operator, in this case for electricity and gas being natural gas and biogas. What many people don't know is that beyond just owning and operating a lot of cables and pipelines, we also do a lot of work in designing energy markets, and we also balance our energy grids. So in terms of the electricity grid, maintaining a balance of 50 hertz is something that is easy to say and difficult to do. We do the same in terms of gas, and that is basically the responsibility of a transmission system operator. Each country in the world has either one or two. An electricity system or a gas system couldn't really function without it.
Nice. So my next question, of course, goes into, we are here, and I represent, of course, Concoridum, and you represent Energinet. So can you elaborate, what is this cooperation about?
The cooperation is really about undertaking the challenge of designing our energy system and the way it should be operating or could operate once we move to a setup where we mainly focus on basically financing moving electricity around and moving this to basically a green energy system where you suddenly introduce a whole new economy to the energy system. It's not that we haven't had this perspective before, it's just there's many new perspectives to it. Brought a little slide to exemplify some of it, if you can see over here. So basically the design of the electricity system is what I will take into account now, is pretty much made to support or function as I point over here, where we have basically energy being produced. We don't own energy production. It's commercial companies who owns energy production. It's being transported in the transmission grid. That's where we come in. And then it's being transported further on in the distribution grid. So basically where you as a company or a private citizen, that's the wires that you can see outside of your house or mainly dug underneath the earth of where you live. And then of course ending up with the consumers. That's basically the logics that we've designed the system to begin with, where it's going from big scale, large facility production and a lot of transportation until it ends up with the consumers. The system that we're looking on today is more like this. It's basically a big mesh of integrated actors. Some is producing energy, some is consuming energy, some is transporting all kinds of stuff and of course consuming fuels. Some is agents in between all of this. Something is markets orchestrating all of this. And the challenge that we're trying to overcome is really to go from just basically moving electricity around and making sure that you have markets where you can trade all of these things, to make sure that once you say that you actually consume green energy, we want anyone to be able to actually prove that that is what is being done. It's not enough to say that I've consumed green energy and then like 2 steps down the value chain, it's pure coal being burned off. These things have to be knitted together. And what it takes to do that is a heck of a lot of integrations and data. If we have to integrate all of these things to each other directly, it would become a huge bottleneck. We would become a huge bottleneck. So what we're trying to overcome is to really push this objective out, basically outside of where we operate, but enable the whole market, or enable the citizens to actually prove that energy is green, consume green energy, create new products or sell their green products at a premium price rather than as commodity products. That's what we're trying to achieve.
And as you can see from that slide, green energy is not only a windmill, it can also be solar, and probably in the future can be a lot of other stuff. So
hydrogen, methanol, stored energy. It's a big difference whether stored energy is coming from a green origins or whether it's basically coal being burned off to store energy and then release at a later point.
So one could say that this is kind of like a system that we're starting at a lower point, and then it's building blocks on top of that. And to secure all that, you've also chosen to do it in a different way than what usually is done. I think you have a slide more that you want to show. Can that be true? Because now we're going into to all the data that is behind this and how you are using that. And I think I'm going to direct my question here to Thomas. So, Thomas, if you can elaborate a little bit about the data.
Of course, and thank you for having us. The whole point about making these green certificate is actually to get some sort of certification that is way closer to the underlying physics of the grid. Because electricity is a weird commodity because it has to be used instantly. You cannot really store it in the grid. And the only thing that we've actually found at Energinet is that we can throw some data after it. But how do we actually make this data applicable and actually bring it out and make it valuable as well? Because we have a lot of metering points. I think in Denmark we have 3.5 million metering points, and we have 150,000 production points. So we have a lot of data, and
meter points means in my home I have a meter point.
Exactly.
A corporation has probably more than one.
And now that we talk about metering points, in Denmark all the metering data is actually collected through our company data hub, and this is where all the bills are coming from and all the taxation and all that it entails. So we collect all that data, and we had to figure out a way, how can we actually make some sort of certification that is trustworthy and way closer to the physics of the grid itself. And that has been the challenge that we've undertaken, and we've had quite a few demos where we can track it one-to-one. It's great, but it doesn't really scale, and the solutions we're looking into are the scalable ones. And that is where you guys come into the picture, because that expertise was not really in our backyard. And that's why it's been a pleasure to actually have this collaboration.
So you talk about the certificates, and can you talk a little bit about what those certificates are like?
Yes, we've had some existing certificates. It's called guarantees of origin. They've been in operation for at least 20 years. And that kind of started this green transition where we had 1% penetration of renewables up to 20 or more at the moment. And at times in Denmark, we have more than 100% penetration of renewables. So it's a great success, but there are some things where it doesn't really align with reality. And it's based on volume-based yearly certificates at a megawatt hour level. And you would never consume a megawatt hour at your home. Not at all. And that is where the problem comes in. So it's huge amounts, it's yearly accounting, and it's more of a paper exercise that has gone digital instead of actually something where you can use the fine-grained data that we actually acquire through the metering points and then apply them in a way that's way more closer to the actual physics. So it's a centralized solution. We call it low resolution, a solution. And where we want to go with this is actually get into these granular certificates, as we call them.
So what I call the old way is that there's a big bathtub, and everybody has something going into that bathtub, and you don't really know what is what. No. And what you're trying to do is the thing to the right. Am I correct?
Yes.
Or kind of like
I would call it specificity of your energy consumption. So you can actually choose, well, I want only wind from these turbines. You could actually do that with granular certification, because all producers would have a certificate issued on a hourly basis, or when the spot market goes to 15 minutes on a 15-minute basis, and have that issued, and then it becomes a commodity that's tradable and can be claimed as well by the end consumer. So the end consumer can go out and say, I only want from a specific windmill manufacturer, whatever their likings are in an open marketplace.
So you will get a certificate every hour on a specific amount of green electricity, and you will have a certificate behind that.
Yes, and that happens for both producers and consumers in the system.
And so I could add that it's kind of a natural progression in that in the last 10 years, most of Europe has done or is moving towards a much more finely grained commodity-based design, so basically hourly or quarterly settlement on energy commodities. And the idea here is basically to take this origin perspective and move that alongside that, instead of sticking to the old yearly or quarterly based setup.
And the old way was also having an Excel sheet saying that this is what I bought and this is what I used, and then everything is fine. And now with the new legislation that comes with ESG, where the board is actually reliable for accuracy when it comes to ESG, I think they want more than just an Excel sheet.
Yes.
And this will actually cater for this. So what is this energy track and trace that we are talking about? I think this question probably also goes to you, Thomas. The energy track and trace, how do
energy track and
understand
trace
that?
Is more of a working group of TSOs trying to actually make the foundations of a market for these granular certificates. And we're working on the technical side of things. We understand that it has to be some sort of decentralized solution. That's why blockchains are an immediate fit. And what we have done is we're working with Elring, Elia Group, which is the German-Belgian one, and Elring is from Estonia, and with the Dutch Vertiser, which is a TSO on electricity and gas in Holland. So it's already international in that regard. What we had to do in Energy Track and Trace, and you can find it on energytrackandtrace.com, was actually describe this whole feasibility of such a solution and get that aligned with legislation. So we didn't end up building a solution that would not be legible, because otherwise it would be counterproductive to actually go into the technical nitty-gritty details before we actually knew it was a viable solution.
So one of the other questions I got from our community, they of course look at Energinet and think this is a fantastic use case for us. But what about the rest of Europe? And what is that cooperation about with and why rest of Europe?
I think it's very important to understand that anything connected to energy in Europe is basically European legislation, European standardization, European working groups. So anything we would do in a Danish local context wouldn't really work if we didn't have an international design pattern for it to begin with. So, for instance, to cater for the customers asking for these solutions, many of them has already invested in wind turbines in England or in Ireland or Finland, which is of course how things should be. It's a very big machine, and it doesn't stop at our national borders. Energy flows. So designing a national only solution wouldn't really work. Could work for a short time, but not in a scalable way. So we have to make this work across borders. That's how we make most energy regulations work. So to begin with, we started with doing some demos in a Danish context, talking with other commercial companies, customers around the world, asking for some of these functionalities about where do they operate, who is really interested in these perspectives, and then quickly found out that we were a bunch of both TSOs but also commercial actors in the European sphere of energy design, energy market design, energy commodity sales, designs and standardizations or data standards, and trying to get a small group together to pan out, okay, how will this work if we are to introduce this in not just one country but in several countries, but introduce this while at the same time we don't just basically remove the current setup, because we want to introduce this but we also don't want to just kill everything that is to begin with, because that also has a place in society. So we got together with a bunch of the different parties, figuring out, okay, some of them really wanted to work on the technical aspects, some of them really wanted to work on the standardization aspects, and some of them really wanted to work on the legislative aspect. So we have these like 3 or 4 lanes of working where we try to collaborate in small groups and change European legislation, make a proper design, make a proper data standard while not going entirely against the current setup. So it's been quite a journey so far.
Yeah. So, I know one of the questions that our community keep asking is when does it go live? We will come into that later, but because as you can understand now, when André is explaining this, there's a lot of parties in this, and there's a lot of coordination that has to go on. But then that also means that in the long run, you know, there will be a lot of participants coming in and joining this solution, if you can call it like that, or this setup is probably more into it. So this is EU, but is there also something outside EU? Would also work outside EU?
Yeah, you take that?
Yeah, sure. Of course, this is more of global issues as well. So it doesn't really make any sense to just make a small solution for little Denmark. It would have fundamentally zero impact. But what the current solution does is it's actually making waves, and we've had contacts with Emirates on the other side of the pond in the US, who are really interested in this kind of certification. Because when you show a thing that works, people get interested. And that kind of interest had almost blown us backwards. Because yes, we had a pilot out, but what we found was that it was not really scalable. And there's a reason for this, and I'll show that over here. Because when we go to these granular certificates, if we go in down to the 15-minute aligned market, we'll get 35,000 and more certificates per year. That's a lot of individual nodes that you have to keep track of. And these nodes can be subdivided. So it's not really fit for the blockchain space in that regard with that kind of throughput. And we learned that the hard way. So we had, 50 odd users on, and we had to turn off the blockchain itself. We had an instance running, and this is where we had to go back into back to the drawing board and actually figure out a solution that could handle this kind of throughput. And this is where you guys come in.
Yeah. So just so everybody knows, there's 8,760 hours in 1 year.
Yes.
And of course, if it's per 15 minutes, it's 4 times that.
Exactly.
So I know a little bit about that from my early days in this market. So
and there's more than 500 million meters in Europe. Not that we're going to cover all of them with this solution by far, but it's still a lot.
But it's a little bit mind-blowing, right? That me at home in my little apartment, I will have 35,000 issuance of certificates a year if you would put it in one single bucket. So it's a lot of data. So it's within EU and it's also outside the borders. So I'm just thinking about what is, or I can also just state something first, because I think this is a little bit mind-blowing that a public company goes out and makes a solution that is done a little bit outside, and it's open source, and it's in collaboration with different parties. And I think that's, at least I don't see that very often. And could you explain your thinking behind this?
Yeah, I think it's very much linked to where and how we see value being delivered in this setup. Our usual, you could say, playing field as a TSO is working with regulations on markets and energy systems, where regulation always comes down to finding a good compromise. That's a good way to actually legislate. It's a very poor way to design functioning solutions. So once we had started this journey, we had to look at who is actually asking for all of these things, who actually want to do all of these things. And it turns out that it's a big mix of different, both commercial and non-commercial actors. Many of these are citizens wanting to make sure that the electrical vehicle that they've bought doesn't run on coal, so to speak. A lot of the larger corporations, which is global corporations, is going really out of their way to make sure that the energy that they have, or that the energy that they base their, so to say, consumption on, is green. And they are really asking for something which is above that compromise that legislation would give them. So products that wouldn't arrive out of our natural way of working, but also, of course, our natural way of thinking. So, of course, we quickly learned that we are out of where we are normally operate. It's probably not our competence to design these things because we don't have that knowledge to begin with. We would, if we just sit down and design this, we would bring in all the usual market collaborators and say, okay, how do we make a proper market fit on this? So we tried to turn it around and say, okay, let's start with going to as granular a fit as we can, to be as local as we can, to enable peer-to-peer trading and transactions between the owners of the assets, both the ones producing energy, but also the ones consuming energy, and basically open anything in between up. And I think the only way for us to move into that space is to basically open things up, and also stating, as I do now, that in many ways we are doing what we think is a good way to do. We've seen that there's a lot of people who see these things the same way, but we would not be able to design or build this in an ivory tower. So it's really about trying to innovate in public space and opening up for everyone else to develop this with us. The downside for anyone using this is, of course, we won't be opening this up with just a basically thoroughly designed market with all the functionalities that you might dream of. It's really the basic stuff we open up with, and then open up for anyone who wants to work with this, either private citizens or corporations or commercial parties, to build whatever is needed on top of it.
But that's the beauty about open source, isn't it?
Exactly.
So and we get feedback from our community, and they help us if there's also stuff that we're missing. Mm-hmm. So I think that's the beauty of it. So I know that the whole project is massive, and we are part of the project that's called Project Origin. Mm-hmm. Can you, and there's some different parties involved in this, so can you also elaborate a little bit on that?
Of course,
Thomas?
I can. There's a lot of words going about. We've been working on this for quite some time, and just to put it into this Trinity setup where we have these granular certificates in the middle, which is the working thesis. We have energy track and trace, which is the collaboration between TSOs, and where the cross-border exchange, all these kind of regulatory things comes into place. We call them topologies that we need to apply throughout the network, because what we're building right now is in Project Origin, where you guys at Concoridum are working with us, Mjolnir Informatics and the Alexandra Institute here in Denmark have all contributed separately into this common project. And what the project is really about is to create unique and verifiable digital proofs. Because as you know, a copy is cheap in the digital world. How can we actually make it unique? And that was the problem that we were dealing with fundamentally when we met you guys. And Energy Origin, what is that? That is actually us as an issuing body making certificates available for the public. So if you want to have hourly certification or 50-minute certification when we come to that, you can actually sign up for that at energyorigin.dk. Yeah. When it goes live.
We'll give you the links afterwards, and we will also make this presentation available for you. Mm-hmm. So just so I understand it, is you have the Energy Origin, which is which is, you can say locally, how do we handle the green certificates in Denmark, what is produced in Denmark. And then you have the energy track and trace, because these small things that are in the grid, they also travel across the border.
Absolutely.
And what happens when this green energy goes across a border? So back in the days, it was with a spreadsheet again, and nobody really knew, okay, do you use those certificates in Denmark and also in Germany and also in Holland and Switzerland, or how did that work? And of course, that's the whole idea about this cross-border thinking, right?
Absolutely.
So, so it's just so everybody is aware of this. And so you have this unique verifiable digital proofs. So it's a very fancy word. It's even difficult to say.
Yes.
So Thomas, what is that?
What is a unique verifiable digital proof? This is where we come into the blockchain space. It's very interesting.
That we like.
Yes, I know. And this is where we've had a lot of help from Torben Pedersen and Daniel Judy, who's working here at Concoridum, actually crafting a solution where we can take a lot of these transactions and actually make a Merkle proof, a single Merkle proof that we can publish to a blockchain that we do not control. So it's more of an immutable log that we're creating of transactions, and that can be issuance of certificates, that can be the claims on these certificates from production. All these state changes, because a certificate is one of a sudden a stateful object. And these state changes have to be tracked, and you have to be able to actually make a proof of inclusion. And this is what a Merkle proof can do. So I can actually prove it afterwards that I made this state change on my certificate, and that makes it unique. And you don't actually have to look up on our databases to prove that. When you have your proofs, when the transactions have gone through, you can actually verify it through that hash that's been published on the blockchain itself. So that's a neat little feature of Merkle proofs, and it's what you call in the blockchain space a layer 2 solution, but this is for conventional data.
See, Thomas knows a lot about this, and actually Thomas, he promised me that if we have some questions that is very technical, he would stand up here together with Torben Kaaber and Daniel.
Absolutely.
And then go through a very technical discussion that will go over my head. But if there's a need for that, we will of course do that. Do you have another?
I actually don't. No, I think that'll be it.
Yeah.
I have one more thing about the technical stuff, if I may. We also applied the Pedersen commitments for the transactions, because this is actually quite sensitive data that we have out there in the public space. You know, you don't want your metering data out there, so we can actually see who's at home and who's not, at what time of day. I think that is our obligation as a public company, to make sure it doesn't live in the public space. And this is where we applied Pedersen commitments to obfuscate this. They're non-retrievable, so nobody will know what the actual value was. And when we do the claims from the consumer side to the production side, let's say you have a solar panel on your roof, and I want to certify 100 watt hours from you, we actually use a zero knowledge group to deduct that from your certificate and from mine, and then I have a unique claim on the solar, the energy that you produce from your solar panel on my little account. And I think that's a neat feature. That's a way of applying cryptography in a way that actually makes sense.
I think I could add also the use case of larger commercial parties. I mean, there's a lot of production facilities where you, in that facility, would really like to be able to show the world that you're green. But if you show the world your actual data, you would also show them how your operations are working. That'll basically open you up for tax speculation or investment speculation, all kinds of things.
Yeah.
So it's also about protecting commercial assets, or the data as a commercial asset that should be protected.
Yeah. You can think about a listed company where you can see the production goes up and down, and then if it goes down, Probably want to sell that stock. So just we had a question also from one of our community members, and that is a little bit. Can you just talk us through this practical stuff? When you get these certificates, what can you do? When do you get them? How does it work? In essence, that was the question. I can't. I think it's André who will go a little bit into that.
And I have to link back to my previous comment about we haven't at all built this out to everything it could be. So we're starting with a very simple, what we call a PPA setup, where you basically have an entity producing energy and an entity that is consuming energy, and we enable both parties to basically make claims on energies being produced and energies being consumed. Once you have those two claims, you can basically match them together. So a process, if you would use the energy origin system that we have in Denmark, is basically to sign up, add your own private or your corporation's meters. You basically go in with the national digital ID, MitID, and onboard yourself. And then you'd start basically onboard yourself to produce claims. And then every time your meter measures energy going through, making this hourly value, every time that happens, you basically get a certificate of production and consumption, and you could basically trade those things with each other. So what we're working is to design wallets and all kinds of things to basically be able to trade these things, but we haven't made market functions. We just opened it up so that anyone who wants can basically do this for their own system. If they both own production and consumption facilities, they can share their certificates or trade their certificates as a peer-to-peer setup, or you could go in as an agent without being registered. You don't even have to be a registered company. You just build an online service to basically enable people to match these things.
Yeah.
Mm-hmm. And the beauty of the blockchain here is that you can't really cheat with it. You can't double account anything. So it's
very important that on an hourly basis, production and consumption is the same, right?
Yeah.
And within the whole Merkle tree, you will have all the different participants in there.
Yeah.
I don't know how many we have. Is it 3.5 million in Denmark?
I think it's 4.5 actually. It's a lot.
It's a lot.
Yeah.
But they will be in there, packaged in there. So of course, it's not a solution that is made overnight. It takes some time. And
I should add, by the way, just it's quite important that this is all happening after the moment of production. Mm-hmm. So the way we build trust into these setups is that we know already that you can't really trust the meters, because a lot of the times these meters either don't measure anything or measure something faulty. So there is a process linked to legislation where these data is vetted by the distribution company who's responsible for the meters. It's that data that we use that usually comes in the same day or the day after the actual moment of operation. So all of these things is basically happening after the moment of production.
Yes.
Yeah.
You'd still need forecasting service and all kinds of things in order to be able to use this to manage or to shift your consumption and production one way or the other.
So that's part of the TSO's task, is also to predict what's coming, so that we can have electricity every hour or 15 minutes of the day. So I'll now go into some of the questions we've received the last couple of days as well. And the first one is from Oxford, and he's asking, when will this, he actually say, when will Energinet be ready? But he probably means, when will the solution be ready?
It's the production system, not with the concepts of Project Origin, but actually stating certificates and registering these. It's online already. It's working as a test. It's not something that will basically legislatively will be okayed yet. But by the end of this year, everything should be up and running. So we are already there. If you have a Danish company, then you can just go in and test it out.
So for all Danish people, go in on the website and you can test it out there. So next question is, and that's of course something that our community has been asking for a long time. How many transactions will this be? So perhaps, Thomas, you can tell us about not only transactions, but numbers and transactions. And
Well, first of
we
all,
won't hold your-
I have to state that this is not a tamper-proof solution. It's a tamper-evident solution. So everything is done on the post side of things. So when it has happened, what we can do is it's conventional databases, and it's an event-driven architecture. So when you make a transaction, we tally them up, and that depends on the size of the Merkle tree or the height. So if you take 2 to the 20th, so there's 20 layers, we can have 1 million transactions in that and publish that to the blockchain. And that has been one of the main critiques about actually applying the blockchain to this space. Oh, it consumes too much energy and all these kind of things. Yes, it does. However, if we minimize the footprint of the transaction logs, we can actually publish that itself, and then it's going to be way less than it would otherwise be. And the other point is that the registries are decentralized by design. So in Denmark, we'll have 1 or 2 or 3 or 4 or 5 registries, depending on the amount of users. And then they log their transactions and publish them to the blockchain, which we are not at Energinet in control of. So that way we enhance the trust and the transparency in the system.
I hope this answers the question. You're welcome to ask questions online, and we'll also try to answer some of the questions afterwards. So I have one question here, that is one certificate, is that equals 1 kilowatt? It's a good question, I think.
It is.
So he says, is one certificate equal to 1 kilowatt produced on location A in the period between X and Y? An hour perhaps, right?
Yes. The resolution will be on the watt-hour level.
See, that's.
So you'll have 1,000, yes.
Yeah.
And that is where the complexity comes in, because one thing is issuing it. That's not the hard part. The hard part is actually matching it, because we cannot track the electron in the grid. It's impossible.
Yeah.
But we can get to a closer assumption about the claims that we're having about our energy consumption. And I think that is a bit of the magic of this. However, it requires that we can handle up to 1,000 different transactions on that 1 kilowatt hour.
Yeah.
So that is the worst case scenario, that we will have a watt hour from different.
So you go from 1 million kilowatt hours, or 1 million?
1 megawatt, so 1,000 kilowatt hours.
Yes.
Yeah, to watt hours.
Yes.
Yeah. So I mean, just think about it. I think that's a massive number. Okay. So next question we have here is what does the international timeline look like? And I guess the question is about some of the other participants within EU. What are their timelines? And of course, you cannot stand up for what they're working on, but if you have an idea about it.
What we found in energy track and trace is that it's very, very different infrastructures. You have to understand that the whole energy grids are very much legacy systems that has been patched together over the years, and by magic and great engineering, is still working to this day. We take it for granted that we have electricity. Yeah. And that's not an easy feat. However, putting metering points at everything has a different rollout. It's more of national legislation. Our Estonian colleagues, they're completely covered. Denmark is more or less covered. But in Germany, it's only the first things that's going to go live, it's only going to be for enterprises. It's very much different than digitization is not as important in different parts of Europe as it is in Denmark. It's very much a political thing that you want digitization to be at the forefront on every solution, but that is not a shared vision in that regard. But it is emerging that it's becoming a tool to actually mitigate some of the common problems that we have.
So could I add also the working with the rollout of metering in a country which is based on 4 million metering points, as opposed to, let's say, France, where they have 90 million metering points. It's a bit different task. I mean, it's much easier to fathom. It's much easier to make local collaborations in smaller countries. So I think that's also why we see some of the smaller countries, which is more or has been investing further into digitalization years before. That's why you can see it there, but also being basically the place where we create these models, which would then basically expand out to the rest of Europe. That's basically much of the market story that we've seen in terms of energy markets. Much of these things has been designed in the Nordics to begin with, and then expands out.
And in the Nordic, we're also blessed with a Nordic exchange, so we're a little bit forced to it. Some of the questions are a little bit technical, and I think what we will do is afterwards we'll put some words on it online in our channels so that you better understand it, because it is complicated. So next question is, I think you alluded a little bit to it, André, but that is, where will the green certificates be issued and traded? We know where they're going to be issued, because that's, I guess, you. And where are they going to be traded? You answered a little bit earlier.
Yeah, I'd say we don't know. We didn't really go into it to begin with, because we kind of hoped for basically being open as we do now, to see actors out there starting to build solutions on their own, to do basically the same that we did 100 years ago when we started designing the energy system, was that make things move distributed. So if someone sees the need, actually has, you could say, a portfolio of 100 customers, start knitting these things together. So of course this is much for the digital native to be onboarded to create services for themselves, or services that they can either give or sell to others. We're not going to just sit down and make a huge market setup of this. We're not at the scale. It's too immature to make a design. It's too immature to harmonize on all these things, which would be the downsides of us creating a service. So the focus is basically making the functionality, making everything as an API, creating a digital wallet so that everything can be done and built in a distributed manner without having us as the ugly middle party who doesn't really know how to cater for the needs that people have.
Today there exist a lot of participants in the electricity market that is trading and are specialists in that area, and I'm sure some of them will take up this task to do it. So I'm not in doubt of that. So next is very technical, some of this. So we have something about how can you elaborate on the content and the use of zero knowledge proofs and the smart contracts?
All right.
And I think that's you, Thomas.
All right. Well, first of all, we're not using smart contracts in this regard. We're actually using the blockchain as a log for a piece of data. So yes, we could have just logs in our cloud setup as we usually do, but in order to actually make it verifiable and publish it, we're using the blockchain for that exact purpose. So it's more of a way of publishing something we cannot change down the line. Yeah. And if we get a request to actually recreate this proof, we can do that with our with the registry's transactions of that range. And if the hash is not the same, something has been tampered with. So this is where you have the tamper evident part of the solution.
Okay, I have a question that comes in that is about the Merkle tree, and I think we've explained that a little bit, and it could be that we can also do that at a later stage. But a nice one here is, as the first outcomers and learnings are also shared with other operators in other countries, with potential of what is the potential of expanding into Europe? I think we went into it, but if you can, I don't know if that's for you, André.
As I stated before, it's the European potential. If you take the full potential, is basically 500 million meters. But I don't think that's the important part. It's not important to cover everyone with this. It's about to cover, it's about opening up for this value where it's really needed. So you could say where you have electrical vehicles or fleets of electrical vehicles, where you have electrical heating, where you're about to produce hydrogen or e-methanol, all of these things where you're really going on really investing hard in going green. But if you don't think closely enough about it, or if you don't design this right, then you'll end up being worse off than we are today. So basically, if you start producing hydrogen based on coal being burned off, that's stupid.
At a 40% loss.
Exactly. So in a system where everything is integrated today, it's really, really important to make these things be well knitted together. So I think the potential for us is not about the amount of metering points. It's about getting this methodology worked into a lot of the new industries we see where we're saying, okay, this really needs to be green. Otherwise, it's a very poor choice for society to do it.
Yeah.
But it's also so that companies can live up to these requirements that they get from legislators. We can't, I think it's an unfair deal to say, right, you have to live up to all this legislation and not actually provide some tools to actually do that. Yeah. Because then you're at odds.
Yeah. Yeah, I was baffled when we started this work without having these services in place, where we started with talking with some of the first, basically it was farmers who started to have some of the first investments in small hydrogen production facilities, or just bioplants, where they would use 500,000 kroner a year in auditing services, just to having someone take their basically and stamp their data. Yeah. Because that's the only service that was available. So what we hope for here is basically to be able to digitalize this, to enable all of, especially the smaller companies, to focus their investments and operations on the asset and not the proving of things afterwards.
I have one last question here, because I can see the clock is ticking. So it's you've been there a little bit. So it's how are double matches or double claims prevented? Has that been solved yet?
That's an interesting question, to be honest, because you cannot have double claims. I mean, it's known in the blockchain space that is the main feature that is being sold into. But what we have done is that we've made sure that it cannot happen through the Peterson commitments and the zero knowledge proofs on the claims. So what you get is you get a range of each certificate that you can, that is claimed from production to consumption, and that is the unique part. This is where the zero knowledge proofs comes in.
And it is, as I also said in one, I understand it more simple, is that production and consumption matches 100%.
Yes, so and just imagine you have a lot of those
exactly.
on your certificate.
And what is below, of course, is...
And that is what we call a transaction in project oriented.
And I think one important aspect of this, one thing is that you can't cheat within this system, but there is also the existing system of origins. But there is also basically just using the energy mix. Yes. So the way we see it is that we also have the responsibility to make a design where if you claim something in this system, you won't be able to claim the same, or you at least have to basically have a link in between a certificate in the current system and the new system. And you also wouldn't be able to have claims in these two systems without that being represented in the calculations of the energy mix. So that's why it's important for us as the issuing body to basically be orchestrating all of this. Because if we just design this outside of the other systems, then you basically just open up for a new kind of system where you could then, instead of have basically claim the same energy in 3 instances, you could now do it in 4 instances.
Yes, so that would be built-in double counting.
Yeah, so we take responsibility of the whole perspective of this, not just within this system.
Yeah. So in the end, there is a solution around the blockchain, and then there's everything in the back.
Yeah.
That's in my head, at least, and that's the beauty, right? Yeah. So I think we need to, we are a little bit above time here. So I just want to thank our community for all the questions. I want to thank Thomas and André for coming here and telling you about the cooperation that we have, and we love it, of course. And if need be, we will put up a very technical discussion that will be led by some of the clever guys around us. So thanks a lot, guys.
Thanks for having us.
Thank you for having us.